Namaskar my dear friends. Let us talk about how we can select capacitors. So capacitors are basic building blocks of any circuits that we have seen in these like industrial or consumer applications or military applications or space applications, even automotive applications. So wherever you see any circuits, whether it is after regulations or power supplies or like switching, and everywhere there will be capacitors that will be being used. So there are various kinds of capacitors. We have ceramic capacitors, that are chip capacitors. We have electrolytic capacitors, we have film capacitors, we have polymer capacitors. Okay, so in this session we'll try to understand what are the different parameters that we need to take care of, or what are the specification that we need to have in our list before selecting a ceramic capacitor. Okay, so we'll be talking about the best processes of ceramic chip capacitors that we can select. So as you can see, I have taken a snapshot from Vijay Semiconductor. So they provide a various categories of capacitors, like we have electrolytic capacitors, we have ceramic capacitors. So that is the like target in this session. We have energy storage capacitor, film capacitor, polymer capacitors, power heavy current capacitors, we have tantalum capacitors, thin film capacitors, and customized capacitors as well. Our aim is to select ceramic capacitors and what are the different aspects that we need to look into. Okay, so let us list out quickly what are the different parameters that we need to have. So very first thing is we have to have a manufacturer's target, like what are the manufacturers that we need to target on, from which we will be selecting. So I have listed down some of the famous manufacturers of capacitors. So as you can see, we have Samsung Electromagnetics, we have Vijay Semiconductor, we have Walsin, we have Burns, we have TDK, we have Kyocera AVX. So AVX is the main company now, it has been acquired by Kyocera. We have Murata, then we have Worth Electronics, we have Camet. So Camet has been acquired by Yageo now, so it is a Yageo company. Now we have Rome Semiconductor, we have Yageo as I told you. Then we have T's Connectivity, we have Panasonic. Panasonic is one of the best company for aluminum electrolytic capacitors and all. Okay, so our aim is to select various capacitors, and you can concentrate on some of the manufacturers like TDK, Murata, and Samsung Electromechanics. Okay, so these are few companies which are having good amount of capacitors. Okay, TDK, Kyocera VX, Camet, and all. So as we have understood which are the manufacturers, better manufacturers in the world, now we will be having manufacturer part number. Okay, so based on the value of capacitors, or like different aspects of capacitors parameter, we will be landing up on a manufacturer part number that will happen at last. Okay, there comes up description. So description actually gives you an understanding like what is the complete like analysis of your capacitor. Like it is ceramic capacitor, it is having voltage rating, let's say 16 volt. It can have any other voltage rating also. It will be having like values, uh, values parameter, like what is the value of the capacitor. It will be having dielectric information as well, like whether it is X5R, X7R, X7S, or like there are a lot of other like dielectrics. We have COZ or NPO. Then we will be having package also, like whether it is 0402 or 0603. Then 0805, 1206, or 1210, or 1810, 1825, or 2220, or 2225. So various like uh, packages are there. Even we have as low as 0201 package. Okay, which can be utilized in mobile application and all, and where you have to have very much space constant, you will be going ahead with very small capacitors. And whether it is SMD or through hole, like it is surface mountable, or like it is going to be through hole, so all these information will be there in the description. Okay, so with this, what we'll try to understand is what are the various other parameters that we need to have before selecting a capacitor. Is very first thing that you need to have is the capacitance value. So it will depend based on your circuit calculation and circuit design. So it can be of any value, whether it is like zero point 0.1 microfarad, or 1 microfarad, or 10 microfarad, or 22 microfarad, or 47 microfarad, or 100 microfarad, or even 1 picofarad, 0.1 picofarad, or 10 picofarad. Any values can be there. Okay, Now you decide upon your tolerance. So if you have to have very tight tolerance, then you can go ahead with 1% or 2%, but they are very, high cost. So standard capacitors are coming up with around 10%, so plus minus 10% tolerance is better one, and they are very standard ones. So I'll suggest you to go ahead with plus minus 10% tolerance. Plus minus 20% tolerance will be bit lower side, like loose side. So 5% or 10% are recommended. So 10% is the most recommended one that you can have. Voltage rating, it depends upon your applications. Okay, so let's say you have a application of capacitor with let's say 3.3 volt application. Then what will you do? Let's say 0.1 microfarad capacitor or 10 microfarad capacitor. So if it is 10 microfarad capacitor, you can go ahead with 16 volt rating. If it is 0.1 microfarad capacitor, then you have to have little bit higher rating, because lower voltage rating it will not be suitable much. So you can go ahead with 25 volt or 50 volt ratings, okay, for 0.1 microfarad. But for 10 microfarad, 16 volt will be enough, or you can go ahead with even 10 volt, but that will be too tight. So 16 volt or 25 volt will be recommended. So you have to have a recommendation of, or decision of having the voltage rating of the capacitor. So it can be as low as, let's say, like 6.3 volt also are there, okay. Then 10 volt and 16 volt, 35 volt, 50 volt, 25 volt, 100 volt, okay. So these all are available in ceramic chip capacitor. Next comes up is dielectric, that is also called as temperature coefficient. So as I told you, like X5R are very well recommended versatile capacitor. X7R are mostly used these days, and none of the other capacitors are being used, you can say. For mid-range value, let's say 0.1 microfarad to let's say some 47 microfarad range. 0.1 microfarad to around 47 microfarad range, you can use X7R. If you have to have little bit higher values or something like that, or maybe if you want a lower package with high values of capacitors, let's say 10 microfarad, and you need to have 0603 package, then it may not be available in X7R, so you have to go ahead with X5R, okay. Then if you want very stable capacitor, or if you have to have no variation at all, very accurate capacitors, then you can go ahead with COZ or NPO package, okay. So they are very stable capacitor, but they will be available only in low values package, okay. Like higher capacitance values you may not have in COZ or NPO package, okay. Next, coming up with other parameters is we have to have operating temperature range. So operating temperature range, it can be like minus 40 degree centigrade to 155 degree centigrade, or it can be other temperature range as well. Let us say minus 40 degree centigrade to 125 degree centigrade, or even 100 degree centigrade, or 120 how much it is 85 degree centigrade also. But well recommended one will be like minus 40 degree centigrade to 125 degree centigrade, or 140 degree centigrade is better. If you talk about some of the features that you may not get in all the capacitors. Okay, so we have talked about the operating temperature range. So generally these are the temperature ranges that will be there. Then we'll talk about some of the features. So features may not be applicable also, like it can be a high temperature, high voltage, or it can be high Q. Then we have epoxy mountable, we have low loss capacitors, we have low ESR capacitor, we have low ESL capacitor. So ESR is basically equivalent series resistance, or ESL is basically equivalent series inductance. So if it is lower, then it will be better. So these features may not be mentioned in the data sheet or in the capacitors spec, so you can leave these features as well. General purpose capacitor will be more than enough for any applications. Now there comes up ratings. So we have ratings, as you can see, we have it may be mentioned or it can be blank also. So generally AECQ 200, or we have X1 X2 or Y1 Y2. So all these ratings X1 X2 and Y1 Y2 are used for safety purposes and all in SMPS. So you can have that also. So it may not be applicable for all the ceramic chip capacitor that we generally choose, let's say 10 microfarad or 0.1 microfarad capacitors for our general purpose application. There are some manufacturers which are giving us applications also. So they can tell you that it can be used for bypass application or filter application, decoupling applications, or general purpose applications, or like a standard and automotive applications. Okay, so if you have to have automotive application, the rating must be AEC-Q 200. Okay, so that's the understanding. Now other parameters is we have to have mounting type. So mounting type, whether if it is a space constant, and these days generally cheap capacitors are used with SMD package like surface mount package. There are through hole package also available. And as you can see, package case, so package case will be as low as 0201 package with other packages that we just now mentioned. So whichever package you want, you can choose. However, the recommendation will be choose as small as possible. Okay, so if your capacitor size will be as small as possible, your inductance will be lower, and so that there will not be any problem in the circuit. Okay, so if you have to have, let's say, 10 microfarad and you are getting it 0603, it is better, but you may not get 0603, so you will have to go ahead with 0805 or 1206 package. But for 0.1 microfarad capacitor, you definitely go ahead with 0402 if your mounting is not that complex, just 0.1 microfarad. Okay, and dimension of each one of them, let me just take you directly to there. Before that, what we'll do is whenever you have to have a capacitor selected, then you need to see the product status, whether it is active or not. So the product that you have selected, the capacitor part number that you have taken into account, that must be active, or otherwise you can check it through the different tools like Silicon Expert is there, and even distributors like DIgiKey, Mauser are giving some of the like indication like that it is active for, let's say, next 10 years or something like that. Or you can check with manufacturer as well whether the part that we are selecting is good. If you have to have very good capability of your device, let's say it should be IEC standard meeting and UL certified as well as C certification and all, then any component that you are choosing must be ROHS compliant. So the capacitor that you have chosen must be ROHS compliant. Okay. Now a general form of all the capacitor sizes that we will have, so we'll just put this table. So as you can see, I have put a size code and the length, width and height. Okay, or thickness. So before that, I'll tell you from here. As you can see, this is the capacitor that is there, and this is the total length, this is the thickness, and this is the width. Okay, so length, width and thickness. Okay, and you can see any of the data sheet, we will have size code and we will have size with tolerance as well. So 1 mm plus minus 0.05 mm and 0.5 mm and 0.5 mm is thickness. So this is how it is mentioned. So I have taken the same values in a separate table. So you can see 0402 is having 1 cross 0.5 cross 0.5, similar to that. 0603 is having 1.6 cross 0.8 cross 0.8. Similar to that, other values can be taken from this data table. And at the same time, this particular values are taken from Visa Semiconductor. At the same time, what will happen is, for any other manufacturer, if you take, there also length, width and height will be almost same. There may be a little bit variation in the thickness, but length and width will be almost same, because all of them has to be equivalent to each other. Okay, so good. With this, you can have only one parameter that you need to take care of in the characteristics. So I have taken one example. So let us say I have taken 1 microfarad capacitor with 50 volt rating and 0805 package with X7R dielectric from Samsung Electromechanics. Okay, so this is the 10% tolerance capacitor, and the temperature rating is minus 55 degrees centigrade to 125 degrees centigrade. So the characteristic that you have to have in your account is, we should understand what is the frequency and what is the ESR value, that is equivalent series resistance. So as you can see, as my frequency is increasing up to around 10 megahertz, okay, or around 8 megahertz, this is around 8 or close to 7. Okay, so my ESR value has reduced to the minimum, and again it starts increasing. So it started decreasing and then it started increasing again. Okay, so if your application is working around 10 megahertz or something like that, it will be much suitable. But if you have little bit lower ripple frequencies or something like that, then your ESR value may go higher. Okay, so this is versus ripple values. Okay, Similar to that, we have temperature variation also. So what is the capacitor variation, okay, with temperature variation? So as you can see, around 25 degrees centigrade there is no variation, it is 0%, okay. And as you go lower side, let's say up to 5 degrees centigrade, and up to higher side up to 45 degrees centigrade, the capacitance variation is almost zero only, there is no change at all, okay. So it is much suitable for using between 5 degree to 45 degree. But if you go ahead with little bit higher temperature, let's say 100 degree centigrade or 125 degree centigrade, the low, the capacitance has decreased by 0.7, I mean 7% around, like -7 it will be, right? Good. So this is a capacitance variation according to the temperature. Next, why do we talk about voltage rating of a capacitor is, let's say you have to have a requirement of 3.3 volt. So you will not select a capacitor of 3.3 volt rating or 6.3 volt rating. You will go ahead with 16 volt rating, or let's say 25 volt rating or 50 volt rating. Why? As you can see, for this capacitor, till around 3.3 volt or around 3 volt, the capacitance is not changing. But as you go on increasing the voltage, like your DC voltage, the capacitance is decreasing, okay. So with increase in the applied voltage, the capacitance value decreases, okay. So you have to make sure that whatever the value of capacitor that you have chosen, the voltage rating is enough that at the applied voltage the capacitance value is not decreasing, okay. Good. So with this, what we'll do is we'll take some examples. I have given here, like let's say 10 microfarad capacitor with, this is the package size, this is the tolerance 10%, we have 16 volt rating, we have AECQ 200 and X7R Samsung, I have taken from Samsung Electromechanics, and this is the part number, okay, CL21B106K OQNNNZ, okay. Similar to that, I have taken one more 0.1 microfarad capacitor. So your job is to find out the like capacitor part number for this particular value with 0603 package, and these are the other parameters. Similar to that 10 microfarad capacitor, you have to find out with 1206 package, and these are other parameters, and try to put down your findings in the comment box, and we shall be able to check it and let you understand that where your selection was good. You can check any other manufacturers as well, like Camet, Walsin or TDK, Panasonic, like AVX, or Samsung is already there, Visa is there, so any Murata is there, so any other manufacturer also you try to select. So hope you have a good understanding now how to identify a proper capacitor for your different applications. And if you do have any questions regarding the capacitor selections, their package size, how it depends based on different characteristics, let's say applied voltage and what is the variation of capacitors, you put down your questions in the comment box and we shall be able to answer you out as soon as possible. Thank you.